Okay, welcome to my channel once again. Today we are presenting on structures. Okay, it's a concept that I am still trying to wrap my head around. I see them reappearing now and again in C. This past week we were doing a binary trees, and I saw an implementation of structures here, and so I thought that I could just do a presentation on them. Okay, let's just look at an ordinary structure here and we talk about it to see what I'm saying. Okay, here we are. Let's include the necessary headers. I always include a bunch of headers in case I miss out something, because some of these functions tend to use they use different headers, and sometimes it's easy to just miss them. Okay, so I just include a host of headers just to stay safe. Okay, all right, so what am I defining a structure is? I am quite fond of catchy phrases whenever I'm mulling over a concept. So for structures, let's just say they are the container for the programmer work tools. Okay, these work tools are called the members. Let's define a structure that we call person here, and for this person we have members, attributes of a person that you can include, where it's age. You can have age of a person, you can have the name of a person, we can have their salary. Alright, just like that. Okay, there we go. Alright, now we need to access the members of the structure. So many books tend to just regard structures as a record. They are called a record or a blueprint of the tools that one is going to use. So we need to access this blueprint, and we use a dot operator, using the dot operator and instantiation. Now instantiation is a concept that seems to straddle both C and Python. In Python is there in classes, and in C is there in structure. So I think you can draw parallels between the two. Okay, now let's just continue with let's create an instance of the structure person. Let's say the structure, the person, we'll call it Willard, so that we don't keep on continually referring to the structure person, structure person. We just call it Willard. Now an instance of Willard has been created. Now let's say age. We are now accessing the members. We use the dot there. Willard age, let's define my age as 30. Let's say the char name. Okay, let's say string copy. We're copying my name into Willard dot name there. So for my name, let's use the second name there, because I have already defined my name with I've given my first name to the struct person. Okay, to avoid issues now, again I'll come back to that. Once again, let's access a salary there. Let's say 9,000. Okay, let's just print out the second name is is the string. We need a new line. Alright, without dot name. Okay, alright, the age now, while his age is 30, that age that we defined there is an int, so we go to the go over and say without dot age. Alright, now that we have done that, we just return 0 there. We are within the main function here, so main expects an int. Alright, so what did we miss here? Okay, let's go over there. This is a string, so let's specify string size. The elements are 30 at maximum. So yeah, let's see what did you miss. I think this is going to run because we defined a structure there that we named person with these attributes, 3 of them, and then we created an instance there and access the members that we defined there. Okay, let's try and see what's going on there. What do we expect to get? The second name, we got it, and the age there. Alright, so these are basically structures in C. Their implementations differ with the concepts that in which they are implemented. So let's head over to single linked list and see how structures over there are being dealt with. Still C, single linked lists. There are slight differences in the way that they are implemented there. Okay, let's go with the header, standard IO to HD. Let's go with the string .h. Let's go with the standard library. Okay, alright, let's define it. Okay, how are structures in single linked list different from those from the ordinary structure that we just saw? The first point is that we use this one instead of the dot operate. So this sign here is just a combination of the minus sign and the greater sign. That's what we use to access the instances that we will create and to traverse through the single linked list. Okay, so what are single linked list here? These are nodes with the head and the tail and the tail. The nodes contain data, what is this data? Data is data and a pointer to next, and the pointer like this to next are prerequisite attributes. Here, so here we have a attributes that are predefined already. So let's just create a structure that will term number line to demonstrate what you just said there. Okay, this is the number line here. Okay, we have these predefined one. the prerequisite attributes. Without them, well, our structure won't behave the way that we would like to. We have a pointer to next when you're defining a single linked list, like that. Okay, now we're heading over to creating instances, but instead of just creating instances, like I said, that we would expect that there are differences in the way that these structures are implemented as we go along to other complex ones from the basic ones. What are we talking about here? We are saying that we have to allocate memory dynamically for the instances that we will create. Okay, and then what else? Let's head over and let's just go over and create instances then for the structure number line there. The first one we'll call it head and we'll define it as null there. Okay, that's the first part. We just have 3 instances, 3 cells, not one there, because now another one, say struct number line. Okay, node 2 because null. Let's go off again and say number line node 3. Okay, now that we have done that, what's next here? We need to allocate the memory now. Memory, we use malloc for that. Using malloc, this memory we will have to free it. Freeing the memory is crucial to avoid memory leaks at runtime as our programs go bigger. So how do we go about allocating memory? Head equals struct a number line, like that, with a typecast over there, because malloc is said to return a void, so we need to include this typecast here. Just leave it and find out what it does. Size of struct number line, we will have an issue there at compile time. It won't run. Node 1 equals struct number line malloc size of struct number line, like that. Okay, node 2 equals struct number line, like that. Malloc size of the struct number line again, like that. Okay, node 3 equals a struct number line malloc size of a struct number line like that. Okay, we have allocated memory for our instances, a head, node 1, node 2, and node 3 using malloc. Now what is the next step? Now having done that, we need to define the instances and link them using next and data. This data that's here, the prerequisite attribute, now is going to be in use like this. Usually we are also, it's also imperative to check if memory was allocated successfully, but we will leave that part here for our purpose. It won't matter. This presentation is just a basic one. Okay, data, we define the data is 30. Want our head to point to next to equal to node 1. Okay, you say node 1, what's your data? Equals 31. Node 1, we go and say next equals node 2. Is it? Yep, node 2, what's your data? Equals 32. Node 2, next we go to node 3. Node 3, there we go. Now node 3 data equals 33. Node 3 next equals, now we're essentially saying that node 3 is the node, is the tail. I mean, the tail is the penultimate end, should you say so? The penultimate to the end, or the end, it points to an empty cell next to one. Yeah, tail, how do we see? It's a cell that cell that points to now is the tail. Okay, like that. All right, the first cell is the head, the last cell is the tail. Oh, what did I do? All right, having done that, let me check what we did here. We've defined. Okay, now let's just print out this thing. The numbers are, let's see, first number is D. There, let's just print them all at once. Is head. How many instances do we have? 1 2 3 4. 1 2 3 4 of them. New line there, so they are going to be on one line. Let's say head data and not 1, data like that, node 2 like that, node 3 like that. Okay, now that we have done that, it is imperative to always free the memory after use. Okay, after use we dynamically allocated memory there. So now we have to free the instances that we created. Free head, we free the head, we free node 1, we free node 2, free node 3. Alright, like that. Within main, just retain an int there. Let me see if we don't have any alright, like that. Let's go over our code. Let's see what we did there. We defined a structure that we named the number line. Okay, we have to give it a name that best describe its purpose. So this is a number line, just a number, the sequence of numbers to demonstrate that we have to traverse forward in a single linked list. So it's just numbers from 30 up to 33 like that. So what do we expect here? We expect them to print in a single line like that, numbers 30 sequential like that, from 30 to 33. Okay, let's try and run this code. Let's see what we can come up with there. Alright, it compiles successfully. Says that the numbers are 30, 31 and 30, 32 and 33. So this demonstrates the use of the dynamic, I would say, the dynamism of structures in their implementation in many concepts. We saw them ordinarily being used, now we see them within single linked list. Now we also need to present on them in binary trees and any other data structure that will come across. But for today, this presentation ends here. Okay, thank you for watching this long. Ta-da.